be binary subtraction. Here we have table for binary subtraction rule. So 0 minus 0 would be 0. So 1 minus 0 would be 1. 0 minus 1. So 1, take 1 from the following high order digit. So 1 minus 1 would be 0. So these are the rules for binary subtraction. So 0 minus 0, when we subtract 0 from 0, we get 0. So 1 minus 0, when we subtract 0 from 1, we get 1. So 0 minus 1, when we subtract 1 from 0, we get 1. Then we need to borrow 1. So 1 minus 1 is equals to 0, since when we subtract 1 from 1, we get 0. Let's try applying the rules on our given 1, 0, 1, 1, 0, 1, 0 base 2 minus 0, 0, 1, 0, 1, 0 base 2. So solution, let's line up the digits vertically. So step 1, just directly subtract. So 0 minus 0 is 0. Then 1 minus 1 is 0. Then 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 0 is 1. Then 0 minus 0 is 0. 1 minus 0 is 1. So the final answer is 1, 0, 1, 0, 0, 0, 0. What if we subtract 1, 1, 1, 0 base 2 minus 1, 1 base 2? Now we will use the 1's complement. So to do that, we need to cancel some values. So for step number 1, since we have 1, 1, we can add 0, 0 in front of 1, 1. So step 1, 1, 1, 1, 0, then 0, 0, 1, 1. So 0 minus 1 is equals to 1, here 2. So here 0 is less than 1, so we need to borrow 1 from 1. Then let's add 2 to 0. So it will become 1 minus 1 is equals to 0. Now 0 plus 2 is equals to 2. Then we will minus this 2 to 1. So for step 3, since we have here 0 and 0, so directly subtract it. 0 and 0 is equals to 0. Then for step 4, since we have 1 minus 0, so 1 minus 0 is equals to 1. So the final answer is 1, 0, 1, 1 base 2. How about if we use the 2's complement? So the first step is we need to find the subtrahend and minuend. So as we all know that 1, 0, 1 is our subtrahend, and our minuend would be 1, 1, 0. So step 2, find the 1's complement. So we need to find the 1's complement of our subtrahend 1, 0, 1. So if our subtrahend is 1, 0, 1, we need to apply the complement. So it will be 0, 1, 0. Now we need to add 1 to the 1's complement. So from 1, 0, 1, after 1's complement, it is now 0, 1, 0. So So from 0, 1, 0, we need to add 1. So 0, 1, 0, 0 plus 1 is equals to 1. So the new value of the subtrahend is 0, 1, 1. Then again, we need to 2's complement. So final answer for this one is 0, 1, 1. So, sorry. This is our new subtrahend. New subtrahend. So this is our minuend. Okay, now let's add the minuend and subtrahend. So 0 plus 1 is 1, 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1, so 1001 is the final answer. So if you don't understand this part, I have here the detailed solution, so let's discuss it thoroughly. So if we subtract 110 from 101, the answer will be negative because 110 is greater than 101. So 110 is much bigger than 101. So what we need to do is we need to subtract 101 from 110. So then we place the negative sign in the result. So 110 minus 101. Since we are really subtracting 101 to 110, the answer would be negative. So the answer here is 001. So it's negative. To make it positive, this is the step. So first is, since 0 is less than 1, we need to borrow 1. So we need to borrow here. We need to borrow 1 from 1, then let's add 2 to the 0. So 1 becomes 0 and this 0 becomes 2 since we borrow 2 the left side. So 2 minus 1 would be 1. Then 0 minus 0 is 0. Then 1 minus 1 is 0. So the answer is 001. Same answer. What if we have octal subtraction? Find the subtraction of 630 base 8 and 205 base 8. So to do that, we need the step 1, we need 2 minus 0 to 5, so 0 minus 5. So as we know that 0 is less than 5, so we borrow from 3. So 3, this part will become 2 and this 0 will become 8 since we borrow from the 3. So 0 plus 8 is equals to 8. So now this is 8. Then 8, when we minus it to 5, the answer would be 3. Next is step 2. Since we know that 2 is greater than 0, so we can directly subtract it. So 2 minus 0 is equals to 2. So step 3, 6 minus 2. So we can directly subtract it. So 6 minus 2 is equals to 4. So the final answer would be 423 base 8. So how about 321 octal minus 47 in octal? So to do that, here's our step-by-step solution. So since R1 is less than 7, we need to borrow from 2. So this is 1, right? So we need to borrow from 2. So 2 becomes 1, while 1 becomes 9. So we have now 8 plus 1 is equals to 9. So 9 minus 7, it will now become 2. So since this one is 1 and this one is 4, we need to borrow again from 3. So 3 becomes 2 and 1 becomes 8 plus 1. So 1 becomes 9 here. So 1 becomes 9. So 1 plus 8. So 1 plus 8 is equals to 9. So 9 minus 4 is equals to 5. Then 2 minus 0. Since we can directly subtract it, 2 minus 0 is equals to 2. So the final answer would be 252 in base 8. So another example, 25430 base 8 minus 4077 base 8. So 0 minus 7, we need to borrow from 3. So 3 becomes 2 and 0 becomes 8. So 8 minus 7 is equals to 1. Now, since 2 minus 7 would be negative, we need to borrow again from 4. So 4 becomes 3 and 2 becomes 10 since 8 plus 2 is equals to 10. Now we can directly subtract 3 and 0. 3 minus 0 is equals to 3. 5 minus 4 is equals to 1. Then 2 minus 0 is equals to 2. So final answer would be 21331. So hexadecimal, same process. But let's consider that hexadecimal is 16-bit. So for this one, 1CDB minus 0A70. Step-by-step solution would be B minus 0, so D minus 7. So since D is equivalent to 13, so we can say that we can directly subtract 13 minus 7, right? So the answer would be 6. So C minus A, since C is 12 and A is 10, again we can directly subtract it. So 12 minus 10 would be 2. So 1 minus 0, we can directly subtract it. So 1 minus 0 is 1. So final answer is 126B. Next is, this one is the second to the last example. Find subtraction of 20C base 16 minus 7E base 16. So, step 1, since C is less than E, we need to borrow. So, since we can't borrow to 0, we need to borrow to the 2. So 2 becomes 1 and 0 becomes 16. So now we can borrow from this part. 16 minus 1 would be 15. So C is equivalent to 12, right? So 12 plus 16, it will now be 28. So 28 minus 14 is equals to E. Then 15 minus 7, we can directly subtract it. So 15 minus 7 would be 8. 1 minus 0 would be 1. So final answer is 1, 8, E for this hexadecimal. So last example for hexa. So 7F0EB minus F764. So same process, since B can be directly subtracted to 4, so B is equivalent to 11, so 11 minus 4, the answer would be 7, so E minus 6, it can be directly subtracted, so we will have here 8, so 0 minus 7. Now we need to borrow from F. So F will now becomes 14 and 0 will now become 16. Since we are currently subtracting base 16, so 16 minus 7, so the answer would be 9. So 14 is equivalent to E. So 14 minus F, we need to borrow again since we have here 7. This 7 will now become 6 and 14 plus 16, this one, this is our 14 plus 16 would be equal to 30. So 30, now 30 minus 15, since F is 15, the answer would be F. Then 6 minus 0, so we can directly subtract it. The final answer would be 6F987. So this ends our chapter 2 part 3 lecture. So since I will be discussing this for 2 weeks, I would like to inform you that I will be conducting all our sessions as online for 2 weeks. So you need to review and analyze all the solutions. So I will also attach this 40 pages solution for our chapter 2 so that you can review it and you can also take note into your module. So for chapter 2, I'm planning to just include binary, octal, and hexadecimal, multiplication, subtraction, addition, and conversion as part of your quiz 2. While page 26 up until page 30 something, until page 43, I will just discuss this when we meet and return in our F2F lecture.